Okay. Uh, in the last few classes, we were discussing about the different instruments that we do use for measuring you use for the linear measurements. Okay, and there we have seen some of the instruments which we call the non-precision type, and we have seen the non-precision type of this thing, instruments. Uh, yeah, like all these things are non-precision type, and then we have, yeah, all these things we have seen, and then we have seen some precision measuring instruments like vernier, different types of vernier scales, like simple vernier scale, like and yeah, simple. Then we have seen this vernier height gauge, depth gauge, micrometer. We just, and also depth micrometer. This is a same as that one. So all these things we have seen about the linear measurements. Okay. Now, out of that, I think I had shown in the last class a video of how to take the readings out of a vernier yeah, caliper. Now, from this week, the practical online practical classes will start. So I'll show all those things, how to take the measurements with the vernier scale as well as with the micrometer. All these things we will cover in the practical classes. Okay. Now, all these things belongs to what type of, we know there are basically two types. One is line standard and one is end standard. So whatever we have discussed till now, these were all of what? These are all of linear, all of line standard only. Now let us see the n standard also. Well, n standard also because there we take the advantage of the two ends of a component. So uh, another thing also, well, this supporting device we will discuss later on. So let us now move on to that, and for that end standard, one of those is the end standard that we follow is the slip gauge. Okay, in brief, I had mentioned in the earlier classes about this slip gauges. Let me go back to that slip gauge slides. Uh, okay, for that. So let me find out. Yeah, I'm almost there. Yeah. So we talked about the slip gauges. Slip gauge, these are the nothing. Now, well, if I go back a little bit, yeah, this is the line standard and the comparison of different standards like line, end, and well, I just forgot to mention the third one, that is the line, end, and well standard. And we have seen some of the instruments that we use for line standard and the end standard. As you can see here, examples are there already. Yeah, yeah. Uh, yeah. So the steel rules which we used at the non-precision type rather, that was an example of line standard. In standard, this vernier that we use there, we use the two ends of the component. So that comes under the so we call it as a that comes under the end standard. Another one for an end standard is slip gauges. Okay. Now let us see what is the slip gauge, because the slip gauges are very very important inspection tools, and these are also being used for measuring. Mostly they are being used for measuring angle accurately. Well, what are these? Then let us try to understand what is a slip gauge. Yeah. The slip gauge, these are some rectangular blocks of steel having a cross section about 30 to 10 millimeters, as you can see here. Okay, and there's a cross section, but their thicknesses vary. Their thicknesses vary, and they are very, very precise blocks. Okay, we'll see to it, but let me switch over to this one. Now, gauge. What is a slip gauge? This is also, we call it gauge blocks also. Slip gauges are known as gauge blocks, okay, fine. Blocks. They are precise measuring instruments. These slip gauges are universally accepted and standard of length, okay? Slip gauges are rectangular in shape, just now I have mentioned, and they're made up of high-grade steel with very close tolerance. The working face of any slip gauge will be made truly flat and parallel. Okay? Slip gauges will undergo hardening to resist wear and tear. Okay? They will be further heated and cooled down successively to remove the hardening stresses induced during the hardening process. The slip gauge can be made up of tungsten carbide because of its extremely capable of hard and wear resistance. Okay. Uh, okay, just a minute. The size of the slip gauge is permanently marked on any of the measuring faces of individual slip gauge. So this is what is slip gauge. Now, let me go back to the presentation. Yeah, yes. So as you can see, these are rectangular blocks of 13 to 10 cross section, 13 to 10. But what is varying here is varying the other dimensions are being varied. Okay. So as you can see here, this is 20, and the dimension or the measurement or is of that particular block is written in one of these surfaces. Okay. So as you can see here, this is the one uh, which varies. Okay, and what is common here? Common here is this length and width. That is, but this height varies as per the thickness. As per the thickness, remember. So
ओए सीमांतिक क्लास खत्म हो गया क्या बे?
Sir, you are not audible.
Am I audible now?
Yes, sir.
Okay.
Yes, sir.
Okay. So let me share it again. Okay. Now, as I was telling that these slip gauges, they come as in a set, right? And the set comprises of different sizes of slip gauges. And the sizes are marked on the face of the slip gauge, as we have seen in the presentation. And you see, this comes in a box, as you can see here, with different. As you can see, this of different sizes you will find here. All these things are different sizes of the slip gauge. Okay. Now, if I go back here, well, this is the same as this one. And now, when I talk about this, about you know, yeah, you see, these are the standard sets. You will find. Let me. Wow. Okay. Let me come back again. Yeah. Yeah. This comes as in a set, as I mentioned earlier. As you can see here, there is this is a set of a metric set, we call it, because the dimensions are in a millimeter. Okay, so see, there normally you will find these two types of sets. One is a set of M45 and the other is M87. What is there? There are 45 pieces in one, and in the other there are 87 pieces. And how these pieces has been arranged, you find from 1.001 to 1.009, okay, and then 1.01 to 1.09, 1.1 to 1.9, 1 to 9, 10 to 90, and then steps. Steps is 0.001. That means the first one is 1.001, and then next one will be 1.002, and so on and so forth till you go reach 1.009. And there are 9 pieces. Okay. Similarly, second one, 1.01, that is also in the step of 0.01, and there also you will find 9 pieces. Third one is 1.1, and that is 0.1, and step, and you will get another 9 pieces over there. And 1 to 9, 1 and 9. And so, like with this, you will get 45 pieces in when you choose a set of M45. If you choose a set of M87, then the number of pieces are, and the steps are as shown in the chart. So you can choose either M45 or M87 as per your requirement. Okay. Now, I just want to show you how do we do this, how we use these slip gauges for measuring angle. This is an example of how it's set up for measuring an unknown angle. So you see here, yeah. So uh, the workpiece. This is the workpiece as you can show, as you can see here. This workpiece is being uh, is being fixed on this particular. We call it angle plate. I will show you what are the items later on. So these are being fixed there, and then this is the slip gauge arrangement of slip gauge. And how do we have attained this particular height? I will show you next. And this is, we call it a sine bar. We call it a sine bar. So this is being, yeah, we place the sine bar here, and then we adjust the slip gauges so that it can just rest on this one. And this, when we have used the slip gauges, then we know what is the height of this one. And once we know the height, and we know this end-to-end dimension of the sine bar, then we can find out this particular angle. We can find out this particular angle. So this is how the slip gauge it can be used for finding out and uh, finding the value of find out angular value, right? Okay. Now I'll give you an example. But before that, there is another very important thing. How do we fix this? Uh, yeah, how do we fix this? The slip gauges. Now, the slip gauges, this can be placed one above the other, because we know the dimension of this of, and then we know the dimension of each and every slip gauges contained in that particular set. So if I want to say I want to make a height of say 1.0 say 0.5, then from the set I'll take 1.01, and from that one from the set I'll find out, so is there anything related with 0.004. Then if I can put 0.004 here with this, then I can have a value of 1.005. It's somewhat like that. Okay, I'll show you with an example how we can do that. But how do we fix it? How do we fix it? There is a method called ringing of slip gauge. It is not that just simply you just put one above the other. It's not like that. There is a process by which we ring this slip gauges, and this is known as ringing of slip gauges. How we do this? These are the steps. Before using slip gauges, the faces should be clean. One thing, the faces should be clean. Slide the one slip gauge over the other. You see here, this is one slip gauge, another one. You'll have to slide it. You'll have to slide it. Okay, slide it one above the other. Okay, with light pressure. Apply light pressure. This way we can expel the air between the slip gauges faces. So when you do that, any air between the two faces of the slip gauges, that air is being removed. Okay. Then once placed place the one gauge 90° to another gauge by using light pressure, then rotate it clockwise to make them in line. Okay. Okay. As you can see here. So what do you do? This is the steps of ringing. Take the one, slide it here, turn it around, as you can see, keeping a light pressure, right? And then again, bring it back in line with this one, as you can see here, like this. Okay, so push it, place it, and then turn it 90 degree, and then again turn it 90 degree to be in line with the, and that way what happens, you get a perfect length of this one. You can get rid of this particular, of any air trap or that sort of thing. Okay, so that is why this ringing will help to achieve the dimension by summation of the individual slip gauges. The need of clamping is also avoided. So there is no need of clamp. Now what happens here? Actually, what happens? There is a molecular attraction between the two. When you do, when you put it there, put the two pieces like this by the way of ringing, then what happens? The addition means between the two surfaces takes place by means of molecular movement. So that is molecular addition is there. So that is why there is no need of the no need of clamping or any sort of thing. It doesn't require. But again, I tell you one thing: if you keep this thing, you should, remove the slip gauges once your dimension is taken. Why? Because if you don't do this, if you keep it for a long period of time, then what will happen? They, it's you cannot remove one from the other because of the molecular action. By the molecular action, they become so tight that they as if they behave as a single piece. Okay, so so this is how we arrange slip gauges, one above the other. Now let me go back to this one again. Okay, yeah. Now I'll give you an example now. Now we have to find out, but we have to make a dimension of 56.421 millimeter with the help of a set of slip gauges. Okay, so how we can set, how we can make a, a dimension of 56.421 with the help of slip gauge. Now this definitely I require not one, several slip gauges to attain this particular shape, particular value, and the method that I will apply is the ringing. So one above the other, we will go on ringing. Okay. Now how do we do that? Okay. So these are the steps. Just remember these steps. Consider the last decimal first. What is your last decimal? 0.001. Right? Consider this thing first. Okay. Since the gauge of 0.001 is not available, select 1.001 millimeter slip gauge. Why? Just I'll show you. So you'd have 0.001, that gauge is not available in any of these particular set, right? So what we'll choose? We'll choose 1.001. Okay, fine. Now, well, I have chosen this one. So now 56.421 minus 1.001 gives us 55.42 millimeter dimension. Now, okay. Now we'll have to adjust this particular dimension. Okay. Now, second decimal point. Let us consider the second decimal point now. One by one, we are reducing. Second decimal point is 0.02. Again, from the slip gauge, we know that we can we cannot get 0.02, but we can get 1.02, right? So we choose 1.02. Then again, what is remaining now? 55.42 minus 1.02. Now we are left with 54.40 millimeter. Fine. Now, next step. Next step is 1.4 and 3. Let us see. 1.4, yes, and 3, both are there. You see, 1.4 and 3, both are there. So, what do we do now? We are attacking on this 4.4 now. We are trying to remove this 4.4. For that, what you require 1.4 and 3 millimeter. Both are available in the set. So we choose these two. Once we have chosen this one, now what is left here is 50 millimeter dimension. Now this we have to adjust. Okay. And then do we have a 50 millimeter dimension? Yeah, we have 10 to 19. So we can have 50 millimeter size also. So what do we do now? As you can see here, to get a value of 54 point, what are that? 54.421, we can select this slip gauges like this: 50, then 3, then 1.4, then 1.02, then 1.001. If we add them up, this is 56.421. And how do you fix them? By the method called the ringing. One above the other. By ringing, if you can, when we do this, this gives us the value 56.421. And so if in this one, you can set this particular height, and you know that the center distance of sine bar is available. So with the help of this, we know sine theta is equal to perpendicular by hypotenuse. So this is the perpendicular, this is the hypotenuse. So that is why this is known as sine bar. We can calculate it out. Okay, so this is what is slip gauge. Okay. Just a minute. Okay. Now, whenever we are doing this thing, just for example, let me go back again to the presentation. Now, whenever we are taking this setting up this our measurement, then utmost care should be taken so that the surface on which we are setting up this particular all the devices for measuring this particular angle, the surface should be the same. So I will show you here. There are some requirements whenever you take in measurement. It's not only in the case of this one. I'll show you. Yeah, it's gone. You see, these are the supporting devices that you will be requiring. Well, whether you are using a sine bar, or you are using a depth gauge, or you are using a height gauge, or whatever that may be, then you require this sort of supporting devices. And what are there in the supporting devices? There's a plate here, as you can see here. There is a plate here, right? Let me enlarge it. Yeah, there is a plate. This is a surface plate. We call this thing as surface. We consider that this is a very smooth surface. Okay, and then let us say one by one. The first thing that is you require is the surface plate. Yeah, this is the surface plate. Okay, fine. There is some adjustable stands are there so that you can set your surface perfectly horizontal, right? Then you have angle plate. I have shown you in the experiment for finding out the angle with the help of slave gauge. We have used this angle plate, right, to fix the job onto that one. So this is, and what happens here? Just as you just I'll show you this one. Yeah, you see here one face is being placed onto the surface plate, and the other vertical surface is being used for clamping the either the job or the instrument, whatever that, on the so that you can get a perfect right angle, right? Then you have V block. Well, if you have some circular one, then we use a V block like this. This is also placed on the surface plate, and then we put this thing like this. Okay. This is very important. How do you support? This is the spirit level. Why this is spirit level one? Just now I mentioned that if you have to see that whether this is perfectly horizontal or not, what do you do? How you can check it? You can check with the help of this spirit level. Okay. If it is a horizontal one, then bubble should be at the center. If it is not, then bubble will move either this side or this side. Okay. So this is spirit level. So these are the uh, some of the supporting uh, equipments that you require whenever you take some measurement. And it is the same thing is here also, this surface plate. And what is a surface? In metrology, if I can define it, the surface plate is used as a measuring base or a datum surface for testing of flatness of surfaces. Surface plate forms the basis of measurement, remember. And surface plates are widely used in where the inspection is carried out. So whenever the inspection is being carried out, you must have a surface plate. You cannot just use your table or whatever. Apparently, it looks like a very flat surface, or no, you should not do that. You must have a surface plate and keep the item on the surface plate for inspection. That's very important. The top face of the surface plate is designed as truly flat. This is the top plate, and this is this is just to put this sections, as you can see, the reverse side. This gives the strength to this particular surface plate, because your surface plate should not bend under any circumstances. If the temperature is high, it should not bend. It should resist that one. That is why you can see that the back surface of this one. The top face of the surface plate designed as truly flat. The back side of the surface plate is having ribs to increase the structural rigidity to withstand heavy loads. Okay. Okay. I don't know. Okay. Next, we'll talk about. Okay, there's still a little bit time about comparator. Now, by now you know what is an instrument. The instrument is used for taking some measurements, right? Recording some measurements, somewhat like that. Okay. But now, what is this comparator? Now, as I think you remember, in course of my earlier lectures, I mentioned one thing, that say I have produced about 100. I have to produce about 100 components, and all are required to be checked for the dimension. It is requirement. Now, if I start doing this thing with the help of an instrument, each and every one, it's a time consuming. Definitely, it is a time consuming. But there is another way we can do that. What is that? If we can make a certain a gauge sort of, say I just want to measure the length of a shaft, right? Now see what I can do. One way, well, I can check the dimensions each and every one of these particular 100 shafts, but definitely it will be very time consuming. But instead of that, if I can make a gauge sort of gauge by which and then the if I can put the shaft inside and if I can say that it is fitting under that one, then I know this is as per my requirement. Well, let me explain it with a small sketch. Okay, where it is one. Yeah. Okay. Say I have to. This is a shaft. Okay. Forgive me for not drawing it straight. So I have to measure this particular length. Okay, just to explain you this particular length. Now, every time with the help of a scale, I can measure this length. Definitely, why not? Okay, I can measure this one. This is one way. But again, this is a very time consuming, definitely. That is also true. Now, instead of that, if I can make a gauge like this, some sort of like this, I'll show you some sort of a gauge like this. Okay, a gauge like this. Okay, a gauge like this. Then what I can do, I can show you now. As per the dimension, then what I can do here, yeah, 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 yeah. And if I remove this one, oh, okay. So let me go back. Right, right, right. But, yeah. Okay. Now my gauge will look somewhat like that, right? Here it is like this. Then I go back. The gauge was like this. Okay, like this. Now, to check this particular shaft, what I will do quickly, uh, because I have to check about 100 pieces. So what I'll do, I'll take the shaft and I'll see whether this is being passing through this one or not. If it passes, then I know that this component is okay. Okay. So this is what it. So now this is also another way of checking. But here I am not taking all the dimensions. But what I'm doing, I'm just comparing this thing with the help of a gauge, right? And so that I can do the inspection faster. So this is what is a comparator. We don't take the measurement. Comparator doesn't give you the measurement, exact measurement. But it tells you whether your job is okay or not. And this is a very, very important tool so far the inspection goes. Okay. So next, this one will be this one will be our next topic of discussions. I don't know your teacher whether your teacher has joined or not, but this will be our next point of discussions. So if I define it now, the comparator is a precision instrument which is used to compare the dimension of the given component with the actual working standard. So we are just comparing here. We are not making any measurement here. So this is the difference between an instrument and a comparator, right? So this comparator is an indirect type of precision measurement because it will not measure the dimension. It will indicate the difference in measurement between the given component and the working standard. It doesn't show the actual dimension, but it shows the difference from the actual working standard. So this is what is comparator, which we'll cover next. Okay, let me stop the sharing. Let me see whether If teacher is in or not. Okay, let him come. In the meantime, please put on your videos, please. Okay, okay. You don't have any class. Yes, yes. I was just confused over the tomorrow's class. Okay, okay. You can leave. So no problem.
Okay, sir.
Okay, okay. See you in the next class. Okay, right. Right.
Okay, sir.